Right now, less than 80 miles from a city of nearly 300,000 people, one of the most watched volcanoes in North America has gone quiet. Not erupted, not exploded, quiet. And if you know anything about how volcanoes actually work, you know that silence is sometimes the most dangerous word in the entire field of volcanology. For the better part of 2 years, Mount Spurr, sitting across Cook Inlet from Anchorage, Alaska, showed almost every classic warning sign of an approaching eruption: rising earthquakes, swelling ground, escalating gas emissions. Scientists at the Alaska Volcano Observatory were watching it daily, bracing the public, briefing the aviation industry, preparing an entire region for what looked like an inevitable event. And then it stopped. The signals dropped. The alert level came down. On paper, that sounds like good news. It sounds like a threat that has passed. But talk to the people who actually study these systems for a living, and you'll hear a very different tone. Because in volcanology, a system that goes silent after months of escalating unrest does not necessarily mean the danger left. Sometimes it means the danger sealed itself in. Today, we're going to walk through exactly what happened at Mount Spurr, why this volcano in particular should be on your radar even if you've never heard of it before, and why silence, in the specific geological context, is not the same thing as safety. Drop a comment right now. If you live anywhere near an active volcano, or you've ever watched one from a distance not knowing what it was doing underneath, tell me where. I rate every one of these, and if you want the moment anything changes at Spur or at any other volcano we're tracking, subscribe right now. It's free, and it's the only way you'll see the update the second it happens. A thumbs up helps enormously. Let's get to 5,000 likes, so the people who need to see this actually do. Now let's get into it. The volcano most people have never heard of. Mount Spurr is not a household name the way Vesuvius or Fuji are. It sits quietly across Cook Inlet from Anchorage, part of a chain of volcanoes that runs along the northern edge of the Pacific Ring of Fire. But ask anyone at the Alaska Volcano Observatory which volcanoes in the state genuinely worry them, and Spur comes up fast. Not because it erupts constantly. It doesn't. Its last major eruption was in 1992, when an explosive event sent an ash cloud drifting directly over Anchorage, shutting down the airport, coating cars and streets in gray dust, and forcing the city to deal with a hazard most residents had never planned for. Before that, 1953. 2 eruptions in roughly 40 years is not a volcano that goes off constantly. It's a volcano that goes quiet for decades and then, without much warning by human timescales, reminds an entire region what it's capable of. Starting in 2024, Spur began doing something the Alaska Volcano Observatory takes extremely seriously, showing a textbook unrest sequence. Earthquake swarms increased beneath the summit. Ground deformation, meaning the physical swelling of the volcano's surface as magma pushes upward from below, was detected through satellite radar. Gas emissions, the fingerprint of molten rock moving closer to the surface, began rising above background levels. Scientists raised the alert level. Public briefings went out. Airlines were notified because Cook Inlet sits directly beneath some of the busiest trans-Pacific flight corridors on Earth, and volcanic ash is one of the only natural hazards that can genuinely bring down a jet engine mid-flight. For months, it looked like Spur was building toward its 3rd eruption in under a century. And then the signals eased. Earthquake counts dropped, deformation slowed, gas output declined. By the second half of last year, the Alaska Volcano Observatory made the call that most people would read as the all clear. They lowered the alert level, effectively taking Spur off the active watch list it had been sitting on for nearly 2 years. Why it calmed down is not the same as it's over. Here's the part that should genuinely unsettle you. And it has nothing to do with dramatizing the science. It's the science itself. When a volcano's seismic activity and gas output decline after a prolonged period of unrest, there are 2 very different explanations. And from the outside, in the early going, they can look almost identical. The first explanation is the reassuring one. The magma intrusion that was pushing upward simply ran out of energy. It stalled below the surface, cooled, and the system relaxed back toward its normal resting state. This happens more often than people assume. Most volcanic unrest episodes worldwide never actually culminate in an eruption. The rock groans, the ground swells a little, and then nothing happens for years. This is very likely part of what's going on at Spur, and it's the reason scientists felt confident enough to lower the alert level in the first place. The second explanation is the one that keeps volcanologists up at night. Sometimes a decline in surface signals doesn't mean the magma gave up. It means the pathway the gas was using to vent up through the rock has become blocked. Volcanic systems are, at their core, pressure systems. Magma carries dissolved gas the way a sealed soda bottle carries carbon dioxide. As long as that gas has a way to escape, whether through fractures, vents, or a permeable plug of rock, the pressure bleeds off gradually and safely. But if minerals precipitate out of solution and seal those pathways, or if a plug of cooled, solidified rock forms in the upper conduit, The gas stops escaping and starts accumulating instead. From the surface, this can look exactly like calming down. Seismicity drops because the magma isn't actively fracturing new rock. Gas readings drop because the gas is no longer reaching the surface to be measured. Everything on the monitoring dashboard trends in the reassuring direction, while underground, pressure is building against a cap that eventually has to give. This is not a hypothetical pattern invented for a video script. It's a documented mechanism behind some of the most violent eruptions in recorded history, where a period of reduced surface activity preceded a much larger explosive event once the sealed system finally failed. That's why volcanologists describe true volcanic quiescence and dangerous conduit sealing as lookalikes in the early stages, and why alert-level decisions are treated with real caution rather than relief. What makes Spur specifically worth worrying about? Geography is the reason Spur punches so far above its name recognition. Anchorage sits close enough that a repeat of the 1992 ash event would not be an abstract inconvenience. It would mean ash fall across a metro area of nearly 300,000 people, road conditions turning hazardous as fine volcanic glass particles coat pavement, HVAC and engine air filters clogging across the city, and a public health concern for anyone with respiratory conditions who inhales airborne ash for days afterward. But the aviation risk is arguably even bigger than the ground-level risk. Cook Inlet sits beneath heavily trafficked polar and trans-Pacific air routes connecting North America to Asia. Volcanic ash is composed of pulverized rock and glass, not the soft soot people often picture. When a jet engine ingests it at cruising altitude, the ash melts inside the superheated combustion chamber and resolidifies on turbine blades, which can cause a total loss of engine power. This is not theoretical. It has happened to commercial aircraft before in incidents that came terrifyingly close to catastrophic outcomes. And it's the reason aviation authorities treat any ash-producing eruption in this corridor as an immediate, all-hands event. A significant eruption at Spur wouldn't just be a regional Alaska story. It would ripple through international flight paths within hours. The honest, non-dramatized bottom line. Let's be clear about what current data actually supports, because the goal here isn't to manufacture panic over something scientists have, by their own assessment, downgraded. The Alaska Volcano Observatory lowered Spur's alert level because the monitored signals genuinely declined. The most likely read, based on the data available, is that the specific intrusion is winding down without erupting. That's the majority probability outcome, and it's the one the agency's own alert level decision reflects. What this video is pointing at is the honest uncertainty that sits underneath that headline. Volcanology is not a field where scientists can look at a chart and declare with total certainty which of the two explanations is happening beneath the surface. Reduced monitoring signals are consistent with both a genuinely calming system and a sealing, pressurizing one. And the only way to fully distinguish them, in many real-world cases, has been watching what happens next. That is precisely why the Alaska Volcano Observatory keeps monitoring equipment active at Spur, even after lowering the alert level, rather than walking away from the mountain entirely. Quiet in volcano monitoring earns continued attention. It doesn't earn a shrug. A pattern worth understanding wherever you live. If there's a broader lesson in this story, it's the same one that applies to earthquake risk, hurricane forecasting, or any hazard governed by systems humans can measure but not fully predict. The absence of an obvious warning sign is not proof of safety. It's a gap in what we currently know. Volcanoes operate on timescales that make human patience look laughably short. A magma system can sit essentially still for decades and then reactivate over a period of months. It can also ramp up, stall, and quietly reset without ever producing an eruption at all. Both of those outcomes are normal. And what makes Spur worth tracking isn't that an eruption is guaranteed. It's that the system spent 2 years demonstrating it has the energy to potentially produce one, and the current lull hasn't ruled that out. It's just changed what the surface is telling us. If you live in or fly through this part of the world, here's what's actually useful. Not fear for its own sake. The Alaska Volcano Observatory publishes public updates and alert level changes for every monitored volcano in the state, and that information is free and immediate. If you're in Anchorage or anywhere in south central Alaska, knowing your region's ashfall guidance in advance, things as simple as sealing indoor air intake, having eye protection and basic masks on hand, and knowing how to protect a vehicle's engine from ash exposure is a genuinely useful use of an afternoon, the same way earthquake or hurricane prep is anywhere else in the world. If you fly through this region regularly for work, it's worth simply knowing that ash advisories exist and how quickly airlines act on them, because when they do, it happens fast. Final thought. Mount Spurr has gone quiet twice before in the last century, and both times, that silence eventually ended in an eruption large enough to shut down a major airport and dust an entire city in ash. That doesn't mean this specific lull ends the same way. Most volcanic unrest, worldwide, quietly fades without producing anything at all, and the current data leans toward that being the more likely outcome here too. But the honest answer to, is the danger over, is that nobody, including the scientists watching this mountain every single day, can tell you that with certainty yet. What they can tell you is what they're watching for next. Renewed earthquake swarms, any sign the ground is swelling again, any gas readings that spike rather than fade. We'll be tracking every one of those signals as they come in, along with every other fault, volcano, and storm system worth understanding rather than fearing blindly. That's what this channel is for. Not manufactured panic and not false comfort either, just the actual science, explained clearly enough that you can make your own informed decisions about the ground and the sky above the places you live. Subscribe so you don't miss it the moment anything changes at Spur. And drop a comment. Have you ever been somewhere during a volcanic ash event or watched a volcano near you go through a cycle like this? I want to hear it. Let's get this one to 5,000 likes so it reaches the people who actually need to see it. See you in the next one.